All right, now I come to my other special case inequality where my inequalities are going to ultimately end up being in different opposite inequalities. So again, we start by solving. Straightforward, nice and easy. First step. So first, addition of the 10, because I'm trying to find the value of v, and first thing to do with that is to attack any additions or subtractions. 6 plus 10 is 16. Divide by -2, remembering that when I'm dividing by a negative in an inequality, I need to change the direction of the inequality symbol. So now I know the value of v, and I know that 16 divided by 2 is -8, divided by -2 is -8, but instead of less than, it needs to become greater than. So that will give me one of the inequalities here. Now I go ahead and solve my second inequality. So first step would be subtracting 12 from both sides of the inequality. Again, performing my normal properties of equality to make sure I'm doing the same thing to both sides of my inequality. 6v is going to be less than -12 minus 12, -24. Again, be careful of dealing with integers. That's probably where I see the most common mistakes. A lot of times people will obviously know their properties of equality, but they're messing up with operations with integers. So make sure you're being careful there. So v is less than -4. So now we think about what this would be. So this tells us that my answer needs to be greater than -8 or less than -4. So let's talk about what that looks like on a number line. So draw on my number line. -8 over here. -4 is bigger than -8. So it needs to be less than -4. So if I were graphing this, less than -4 would be an open circle. So this is my underneath part is kind of like my draft of my graph. And it would go less in the less than direction. So going to the left, greater than -8, open circle, going to the right. So what we can see is that or gives us a lot more flexibility. Or lets me be either one of these, greater than -8 or less than or greater than -4 or less than -8. These two solution sets overlap. So what that's telling me is that any number works for a solution. So my answer here would actually be all numbers because our solution sets overlap. They include each other. So when we have an opposite inequality situation with or, and we are greater than the smaller number and less than the larger number, our answer is all real numbers. That's my solution set. So when they're asking for the solution set, all real numbers, and you may be saying, okay, well, how do I graph that? Well, that's easy. You just draw a line, arrows in either direction, indicating that any number works as a solution. So I could use any number between -8 and -4, so example -6, or any number outside, such as -10, or even a positive number like 7. So that is how you solve and graph a compound inequality, a special case where you have opposite inequalities. So you can see it's not about the solution itself, it's about recognizing what the solution actually indicates. So this is a special case. You don't see this very frequently, but you need to be able to recognize it so that you know how to deal with it in a graph.